Hi, my name is Siam M.
Hello, my name is Sonia. Today we would like to share with you about a topic that is semiconductor. So let's start. In this topic you will learn 3 subtopics about semiconductor. First is explain the structure of atoms. Second is identify the classification of electron conduction material. Third is classify energy band. Who is the founder of Bohr atomic theory? He is Niels Bohr, in full Niels Henrik David Bohr, was born October 7, 1885, at Copenhagen, Denmark and was died November 18, 1962, also at Copenhagen, Danish physicist who is generally regarded as one of the foremost physicists of the 20th century. He was the first to apply the quantum concept, which restricts the energy of a system to certain discrete values, to the problem of atomic and molecular structure. For that work he received the Nobel Prize for Physics in 1922. According to Bohr, atoms have a planetary structure that consists of a central nucleus, surrounded by orbiting atom is a basic unit of elements. They can change some particle nucleus and have electron cloud around the nucleus. The atomic particle include protons and neutron which is located in nucleus and the electron which located in electron cloud. Proton has a positive charge as neutrons is no charge and electron is negative charge. The number of proton and electron are same. If we can see it elements of carbon, there are 6 proton, 6 electron and in most cases has 6 neutron. We can see it in shell or rings around the nucleus. The shell represent different energy level. For example, helium. There is 1 shell or energy level. First shell can only have 2 electrons, so helium is stable. If an atom that has more than 1 shell, 8 electrons are required in outermost shell for stability. For example, neon that have 8 electrons at outermost shell are stable while oxygen only have 6 electrons at outermost shell is chemically reactive. Atoms that do have fewer than 8 electrons in their outermost shell will try to shake, gain, or lose in order to become stable. This is called octet rule, but there are some expectations such as we saw hydrogen and helium which only have 1 energy level or shell.
Semiconductor are further divided into intrinsic and extrinsic semiconductor depending on structure properties. Do you know what intrinsic means? It means in its purest form. Therefore these types of semiconductor are in their purest form by the nature of their existence. The common semiconductor use are silicon and germanium. They have 4 valence electron orbiting in its outermost shell. We can further understand motion of these electrons by looking at the structure of the atom. However, the atom needs a total of 8 electrons in the outer shell to become stable. Okay guys, pay attention please. Okay, now let's see how the semiconductor atom acquires the additional 4 electron become stable. Let's first look at this process with the helps of one atom. The electron already have 4 valence electron and required an additional 4 become stable, which it share with its neighbor atom so that every silicon atom has 8 electron in its outermost shell. The atom are bonded together and they form semiconductor structure which looks like this. All these atoms set up a bond with each other that called as a covalent bond. However, the bond are so strong that the electron fails to break the bond at 0 Kelvin, but as the temperature increase the electron absorb the heat energy and it is able to break the bond. Once the bond are broken, the electron become free to carry the current. We get a deficiency of an electron in the structure, hence there are empty space. How they are different from the intrinsic semiconductor. While intrinsic are the pure form of semiconductor, impurities need to be added to the intrinsic to improve their conductivity, and these semiconductor with impurities are called as extrinsic semiconductor.
Extrinsic semiconductor are further subdivided into p-type or trivalent and n-types or pentavalent. Seriously, please pay attention. This is important. This is important process of adding these impurities to intrinsic semiconductor is called as doping, and the impurities that improve the conductivity of semiconductor are called as dopant. In case of trivalent, 3 electron of boron will form 3 bond with silicon and the 4th bond of silicon. There will be 1 empty space or hole, and as seen previously the immediately neighboring electron will be attracted toward the hole, thus creating another empty in its previous location simultaneously. The electron of the silicon atom add in thermal energy and keep breaking the covalent bond at room temperature, thus creating further free electron, and this movement will go on in the same manner. Therefore the number of hole generated in this structure dominates over the electron, hence this structure are called as a p.
Next we move to second types of extrinsic semiconductor, that is the n-types or pentavalent semiconductor. In this atomic structure of the n-types of interbulance semiconductor will have 5 electron in the outermost shell, as silicon requires only 4 additional electron to attain stability. In pentavalent atom we have 1 extra electron as a valence electron. So we get the net negative charge due to this extra electron, hence its name is n-type semiconductor. When we add pentavalent impurities to an intrinsic semiconductor, we observe that the phosphorus atom form 4 bond with 4 silicon atom, fulfilling the need of silicon, but even after that there remain 1 electron which does not form any bond and remain free in sunlight. The previous structure here we get free electron readily available for conduction. The electron rotate randomly around the phosphorus atom following circular motion. In addition to this, breaking bond is seen in the intrinsic semiconductor. Next is material classification. There are 3 types of semiconductor. First is conductor, low resistance, which allows electrical current flow. Charge flows freely. Example is gold and copper. Second is insulator. High resistance, which suppresses electrical current flow. Almost no charge flows, such as ceramic, plastic. Third is semiconductor. Can allow or suppress electrical current flow. Conductivity lies between conductor and insulator. Silicon, germanium.
Larger number of electrons being excited into the conduction band, leaving a larger number of holes in the valence band.
Wait, we had prepared some questions as your test after watching this video. We will pass it by link.